Hello everyone, in this video we are just going to interface 16x2 LCD in 8-bit mode with the Renesas microcontroller RL78 bar F14. And now as the first step we are just going to discuss about the schematic diagram that we are going to build in a breadboard for interfacing this 16x2 LCD with RL78 bar F14 series microcontroller. So on the screen you can clearly see this is the LCD schematic. It is having totally 16 pins, and the first pin is nothing but the VSS, to which we are just going to provide the ground of the circuit. So we will be connecting this VSS pin of the LCD to the ground of the development board, and the second pin is nothing but the VDD pin of the LCD, through which we will be powering up the LCD module. So this VDD pin will be connected to VDD of the development board that we are using, and the third pin is nothing but the contrast pin, which is useful for varying the contrast of the font that is being displayed in the LCD. So to this particular pin we will be connecting a variable resistor of 10 kilo ohms. So you can clearly see, as per the schematic, we will be connecting a potentiometer or variable resistor center pin, and other end of variable resistor we will be connecting it to VDD, and also one of the end will be connected to ground of the circuit. And the next three following pins are RS, RW and enable, which are pin number 4, 5 and 6 of the LCD module. So these three pins are nothing but LCD configuration lines. So we will be connecting these particular pins to output pins of the microcontroller, and following that 8 pins starting from pin number 7 till pin number 14 of the LCD are data lines of the LCD, through which we will be passing the data to the LCD. Whether it is a command or instruction, we will be passing a 8-bit data with the help of these 8 data lines of the LCD. And following that we are having two particular pins, pin number 15 and 16, which is meant for backlight of the LCD. So anode of the backlight, that is the pin number 15, will be connected to VDD through a resistor, particular value of resistor. So as per the brightness requirement you have or you require, you can add the resistance value, and if the amount of resistance increases, the brightness will be dimmed, but don't go less than 1 kilo ohm resistor, because that could damage the LED. And finally the 16th pin of the LCD will be connected to ground of the development board, which is the ground of backlight of LCD. And now let us discuss in detail the pinout connections of this particular LCD module with the development board or to our microcontroller that we are using. So we will be utilizing this particular CN1 connector of the development board for interfacing this LCD in 8-bit mode. So the microcontroller pinouts are directly provided in this CN1 and CN2 connector, and the schematic diagram of the CN1 connector you can see right over here. This is the separate schematic diagram of the CN1 connector. So pin number 23 is VDD of the development board. So we will be powering up the LCD with the help of this VDD, and pin number 43 of the CN1 connector is the ground of the development board. So we will be connecting this particular 43 to the ground of the LCD module. And other than that, we will be utilizing all these pins P61, 63, 65, 67, P155, 156, 140, 77, 75, 72, 70, 32 for connecting configuration lines RS, RW enable, and also data lines from D0 to D7 of the LCD. So let us see in detail what are all the pins to which the data lines and configuration lines of the LCDs will be connected. So you can clearly see, as I mentioned, VDD will be connected to VDD of the LCD, both the VDD of the anode of the LCD and also the VDD of the LCD right over here, pin number 2 and pin number 15. And the ground will be connected to ground of the development board, as I mentioned before. And regarding the data lines of the LCD, starting from D0 to D7, I will be connecting it between connector pin numbers 25 to 41. That is D0 will be connected to P61, D1 will be connected to P65, D2 will be connected to P67, D3 will be connected to P155, D4 will be connected to P156, D5 will be connected to P140, D6 will be connected to P77, D7 will be connected to P75. and the configuration lines such as RS, RW and enable will be connected to P72 and RW will be connected to P70 and enable will be connected to P32. So as per this circuit diagram, you can clearly see I am just utilizing all the continuous pins available in this rail's outer terminal. So this also makes me ease for connecting the LCD to my development board. That is why I have chosen these lines, and irrespective of this particular connection, you can connect to any pins you want to this microcontroller or to similar RL78 microcontroller, so that you just want to do the correct configuration for interfacing this LCD. That's it. But the method is same. You can follow the same steps that I'm following in this video for connecting the LCD and getting your output as per your microcontroller and the pinout diagram that you are connecting. So this is what the connection that I'm going to make, and the extra circuit that I'm going to build is this potentiometer circuit for VEE for varying the contrast of the font that is displayed in the LCD, and also the anode of the backlight of the LCD will be connected to VDD through 10 kilo ohms resistor. So if you don't connect this 15th and 16th pin, that is also no issue. Only the backlight will not be lighted up. Instead, all the functionalities will be same. The printing operation will be done, but the only difference is the backlight will not be turned on. That's it. You can also neglect these two connections, that is the anode and cathode, 15th and 16th pin connection of the LCD. So this is the circuit diagram that I am going to build for interfacing this LCD in 8-bit mode with our microcontroller. So now let us try to open the CubeSuit Plus for CCRL IDE for creating our project for the microcontroller. You can see in this IDE opened, I'm just going to create my new project. Just click on the project tab in the top of the window and then hover over this create new project and click on it for creating your new project. And in the window that is popping out, just type in the microcontroller name. In my case, I'm just typing R5F10PPJ, and you can see the highlighted microcontroller will be selected by default. So just cross verify that the pin number is correct for your microcontroller. In my case, it is 100 pin, it is correct. So I'm just leaving it. Or if it is anything different like this one or this one, just click and select anything as per your requirement. Just left click and select it as per your requirement. And once after selecting the microcontroller, just provide a name for your project in this project name tab. I'm just providing it to be Pro. And in place of this place tab, just click on this browse button for selecting the repository or directory in your local folders where you want the project to be stored. So let me just make a folder right over here, RL78, and I'm selecting that folder and I'm clicking on the create button for creating my project for this particular microcontroller selected. You can see on the left of the IDE we are having a particular tab called project tree. So this particular tab will be containing several segments of the microcontroller. Those are very important. First and foremost segment is the pin configurator segment, and next segment is the code generator segment, and the next segment is the file segment. So these three are the major segments that is generated for your microcontroller. So this pin configurator segment is useful for visualizing the configurations that has been done for your particular microcontroller. So when I double click on this device top view, you can clearly see this is the layout diagram of my microcontroller RL78 bar F14, that is R5F10PPJ. You can see each pin description has been provided right over here. Once the configurations is done, you can see the configurations that has been done as a whole in this layout. So for that purpose, this pin configurator has been provided. So using this code generator segment right over here, you will be able to generate your own base peripheral software that is required for your microcontroller as per your user application. So I will be showing you how to configure your microcontroller in a while as per your application needs. But before that, we just want to do some basic configurations that needs to be done for almost all the programs. Just double click on this clock generator tab inside the code generator, and you can see these configurations, that is the default configurations that needs to be fixed in the microcontroller before moving on. So let's take an example. This particular PIOR00 is yet to be assigned to the function TI00, and the respective port pin for that function is P17 by default. So if you need any alternate port pin to be configured for this function, let's check it out. Just click on this drop down. You can see the alternate pin that can be assigned with the same function is P66. So if you want that particular pin to have this feature, you just want to select that. So most often we will not be changing anything right over here. We can use all these functions for all these pins as it is. So if in case anything is required, I will just intimate you in future lecture videos. But for now, we will be fixing these settings by default. Just click on fix settings for fixing these settings as default settings in this microcontroller. Once that is done, just click on chip debug settings tab right over here, and this is a tab which is useful for enabling the debug option in your microcontroller. So if this is disabled, you will not be able to program your microcontroller using debugger, or you will not be able to debug your microcontroller using debuggers like E1, E2, E2 Lite, etc. So for that, just click on used radio button right over here. In my case, I'm just going to select the E1 right over here. If you are using any other emulators like E2 or E2 Lite, you just want to select the respective radio buttons right over here. So in my case, I'm just leaving this to be E1 selected. That's all about the basic configurations that you want to do. In addition to that, just double click on this watchdog timer right over here in the project tree inside the code generator, and you can see by default this watchdog timer is enabled, or it is used by the code generator. So you just want to disable it. So I will teach you what is this watchdog and how to configure this watchdog in this microcontroller in a separate video. And for now, for almost all the videos, I will be disabling this watchdog, and in a separate video we will learn how to enable the watchdog and how to utilize its features for safeguarding our microcontroller. That's it. These are all the required basic configurations that you want to do for almost all the programs. So now let's just move for configuring our microcontroller as per our application needs. So on the screen you can see these are the pins of the microcontroller to which the LCD terminals are connected. So these are derived from the schematic that I have explained you just before in the initial segment of the video. D0 is connected to 6.3 pin of the microcontroller, D1 is connected to 6.5 pin of the microcontroller respectively, and it goes on like this respectively. So now we are just going to configure all these pins right over here as output pins before writing down our logic for interfacing LCD displays to our microcontroller. So double click on this port. The first and foremost pin is the port 6 pin number 3, port 6 pin number 5 and port 6 pin number 7. So I just want to configure these 3 pins in port 6 as output pins. So select the port 6 tab after coming to the port configuration right over here, and here I just want the P63, P65 and P67 to be configured as output. Just click on the out radio button for configuring that particular pin as output. And then in the port 15 I just want the port pin number 5 and 6 to be configured as output in port 15. So click on the port 15 tab and select 5, 1, 6 as output pins. And then in port number 14 I just want the 0th pin to be configured as output. Select or click on the port 14 and click on the out radio button right over here for configuring this P140 as output pin. And in the port 7 I just need P70, 72, 75, 77 to be configured as output. Coming to the port 7, I just want 70, 72, 75, 77 to be configured as output. And in port 3, I just need a second pin as configured as output for connecting that particular pin on enable pin of the LCD. Coming to the port 3, I just want to configure pin 2 as output pin. So now that the configurations are done, all the pins that needs to be configured as output for interfacing LCD display to our microcontroller has been configured. Now I just want to generate the base drivers required for writing down the interface code for interfacing LCD display, that is 16x2 LCD display in 8-bit mode with our Renesas microcontroller RL78 bar F14. So just click on this generate code for generating the base drivers required for the configurations done right over here. The code has been generated. Now coming inside the code generator, just click on the plus icon right over here and you can see the main.c file. So we can start writing our application code for interfacing LCD with our RL78 bar F14 series microcontroller right over here in this main.c source file. So let's start writing the logic for printing something onto our LCD with the help of this configuration done. So coming to the logical part of interfacing 16x2 LCD in 8-bit mode with this microcontroller, we are just going to use the previous program that we wrote for interfacing 7-segment display with our microcontroller also. So this is the program that we wrote for interfacing 7-segment display with our RL78 bar F14 series microcontroller. So in this program, we just wrote this print data function. So this function is a very simple function which will help us to turn on a particular pin and also for turning off a particular pin based on the individual bit status that has been passed as a byte of data as parameter to this function. That is, whenever you pass a byte of data as a parameter to this function, that particular byte of data will be converted into 8 individual bits. As we know, 1 byte is equal to 8 bits. And 8 individual bits will be starting from bit number 0 to bit number 7. And based on each individual bit status, starting from bit 0 to bit 7, one particular pin will be toggling its state based on that particular individual bit status. That is, for example, if you take the bit number 0, if the bit number 0 in this byte of data is having the value 1, the pin corresponding to that bit number 0 will be turned on. And if that particular bit is having the value 0, that particular pin will be turned off. So this is what happens for all the 8 bits available in the byte of data that we are passing as a parameter to this function. So we are just going to use the same function right over here for passing the data to the 8-bit data port of LCD in our program. So I'm just going to copy this. I'm just going to copy these two functions, that is delay function and also the print data function. And I'm going to paste it right over here before the main. And also the pin namings also you can clearly see I have not changed the data pin namings also. To the pin P63, D0 is connected. So this is not A of 7 segment, this is D0 of LCD. And to the pin P65, B is connected. You can see D1 is connected for P65. D2 is connected for P67. You can see D2 is connected for P67. D3 is connected for bit number 3. D4 is connected for bit number 4 and P156. So this is not changed. You can clearly see every pin namings is common as compared to the previous program where we interfaced 7-segment display to our microcontroller. The only change is, in addition to all the 8 bits available right over here, we are having 3 more pins for interfacing this LCD, that is RS, RW and enable. And regarding all these functionality of all these pins, I have already done a video before this video where I have explained you basic functionality of LCD and how you can interface this LCD to any microcontroller. So in addition to this function, we just need few more functions for interfacing this LCD. So first and foremost function that we need is void LCD data. It also receives a parameter, let's take it to be character data. And the next function that we want to write is LCD command assigned to care of CMD. And next function that we want to write is LCD string assigned care of str unsigned care of length. And finally we just want to write another function called LCD initialize, and this does not need any parameter. So these are the four functions that we are going to write down for interfacing LCD with our RL78 bar F14 series microcontroller. So starting from this function, let us see each and every function and let us build each and every function step by step. So this particular function right over here is useful for passing data to data register of LCD, or it is useful for printing data to LCD. So let me just break down the steps for writing to the data register of LCD or writing some data which needs to be printed on the LCD. So this particular function LCD data is useful for printing some data to the LCD, or it is useful for passing some data to the data register of LCD. Both are same. So the first and foremost step is we just want to pass the data as 8-bit data to data lines D0 to D7 of LCD, and then make RS to be high for writing to data register, and then make RW pin low for enabling write operation in LCD, and make enable pin high for enabling the clock of LCD. Wait here for a certain delay, and finally make the enable pin low for finishing the operation. So these are the steps that we need to perform for writing to the data register of the LCD, or for writing some data which needs to be printed on the LCD. So for this particular line number 1, or for this particular sequence for passing the data as 8-bit data to the data lines of the LCD, we are just going to use this particular function print data. So as we discussed, we already used the same pin nodes as we did in the lecture of interfacing 7-segment display with our RL78 series microcontroller. You can see the A terminal of the 7-segment was connected to P63 in that video. Here D0 terminal of the LCD is connected to P63. Similarly, B terminal of the 7 segment was connected to P65, but here the D1 terminal of the LCD is connected to P65. So I have done in the same manner as I did in the lecture of interfacing 7 segment display with our microcontroller. So I am not going to change anything right over here in this function. I hope you remember this. If you have not watched that, please go back to that where I have wrote this print data function from scratch, to the lecture of interfacing 7 segment display with our RL78 bar F14 series microcontroller. So here what I will do is I will write like print data of the character data. I'm just going to pass this data received as parameter to this function directly to this print data. So here I'm just passing the 8-byte data that is received as parameter to this function to the data lines of LCD. So for passing the data to the data lines as a 8-bit data, we are just using this print data function. So what this print data function does is it will split the 8-bit data into 8 individual bits starting from bit 0 to bit 7, and based on individual bit status, if it is 1, it will turn on the corresponding pin required for that particular bit. If it is 0, it will turn off the particular pin required for the representing that particular bit. And as the next step, I just want to turn on the RS pin. So here I am just going to turn on the RS pin. Second step is complete, and RW pin must be turned low. RW is nothing but 70. P7 is equal to P7 ampersand of negation of 1 left shifted by 0. The third step is also done, and as the next step I just want to make the enable pin high. And here finally I am just going to wait here for a particular amount of rough delay. I am just going to use the same loop delay that we have been using from the beginning lecture of LED blink, that is rough loop delay. So let me just provide a delay of roughly 10,000 value, loop value. It will be around a little bit lower, like 2 to 5 milliseconds. And finally we are just going to turn off the enable pin right over here. So P3 is equal to P3 ampersand of negation of 1 left shifted by 2. So the function for printing the data to the LCD and also the function for passing the data to the data register of LCD is done. So we will be using this LCD data function for printing a byte of data to the LCD. So whatever the data it may be an alphabet or a number, you can directly pass to this function so that that particular data will be printed on the LCD. And coming to the next function, that is the LCD command function, we will be using this function for passing the data to the instruction register of LCD or for passing an instruction to the LCD. So this particular function, let me just write like this particular function is useful for passing the data to the instruction register of LCD or passing instruction to LCD. I'm just copying this. So for passing the instruction to the LCD, we are just going to follow the same methodology only here. The first step is we just want to pass the data as 8-bit data to the data lines of LCD. So here the variable is CMD. So I'm just passing the CMD variable right over here to the same print data for passing the data to the data lines of the LCD from D0 to D7. And as the next step, we just want to make the RS pin low in case of instruction. So I'm just making this low for writing to the instruction register of LCD. And other than that, all these steps are common. We don't want to change anything. That's it. That's all about the function required for passing instruction to LCD. And this particular function, we are just going to use this particular function for writing a string of data to LCD. String of data to LCD. So in this function, we are just going to use a variable. So let me just declare a variable called I is equal to 0, and inside that I'm just going to write for loop of I is equal to 0, I less than length I plus plus, and inside the loop I'm just going to use the same LCD data function, and I'm going to print str of I inside this. So this loop will run to the length of the variable passed as second parameter to this LCD string, and this loop will continuously use this LCD data function right over here for passing continuously the string of data that has been passed as first parameter to this LCD string function. So this will help us to print a string of data to LCD. That is, for example, we can use this function for calling like LCD string of embedded comma. We just want to provide the length of the string right over here. So 3, 4, 5, 6, 7, 8. So 8. So when I call this function in this manner, this embedded will be printed on the LCD display. So that is the purpose of this loop right over here, or the function right over here. And coming to the LCD initialize function, this particular function is useful for initializing the LCD in the beginning stage of the program. So I will be using the LCD command function for initializing the LCD with several commands. So the first and foremost command which I am going to provide for initializing the LCD is 0x38. So this will utilize the 16 columns and 2 rows of LCD. And the next command that I am going to use for initializing this LCD is 0x0c. So this will auto increment cursor to next column when current column has been printed. And LCD command of 0x06 this will do display on and cursor off. LCD command of 0x01 this will clear the screen once. So that's all about the functions required for interfacing LCD to our microcontroller. So as the first step, I'm just going to, so this particular line right over here will bring the cursor of LCD to first row first column of LCD, and following that this particular line will print the string embedded in the first row first column of the LCD, and this particular line will bring the cursor of LCD to second row first column of LCD, and this particular line will print the string systems in the LCD second row first column. So finally we will get embedded systems printed on the LCD. So now as the first step of logical segment of the program, we are just going to call this LCD initialize function in the initial segment of the program just before the while of 1 right over here. So this function call right over here will initialize the 16x2 LCD as per the configuration done. And coming to the while of 1 right over here, so this is the super loop or infinite loop of the program where we will be writing the logical part of the program which needs to be executed again and again until the microcontroller is stopped. And before this while of 1, that is just before this while of 1, the segment inside the main function is the segment of the program which needs to be executed only once in the initial segment of the program. So whatever the configuration lines that you want to do, pin configuration, communication configuration, parameter configurations, that needs to be executed only once in the lifetime of the program, needs to be done just before the while of 1, and inside the while of 1 or infinite loop, we are just going to write down the repeatedly executable statements which needs to be executed again and again until the microcontroller is stopped. So our motto is to print something onto the LCD. So what I will do is I will just call for LCD command function, and I will move the cursor of the LCD to first row first column by providing the command 0x80. So I have explained you in detail about the commands of LCD and all the configurations of LCD and basic working principle of 16x2 LCD in a separate video. I hope you watched that video. In that itself I have explained you the addresses of each and every segment of the LCD in detail. So if you have not watched that video, please go back and watch that video and then come back to this video for better understanding. So when I provide the command of 0x80, the cursor of the LCD will be moved to first row first column, and coming to the first row first column, I will just print the string embedded, and as a second parameter to this LCD string function right over here, we just want to provide the length of the string, that is provided right over here as the first parameter. So here the string provided is embedded. So length of the string is 1, 2, 3, 4, 5, 6, 7, 8. So I will provide 8 right over here. And following that, I will just provide the command 0xC0 for moving the cursor of LCD to second row first column of LCD. And here in the second row first column, I will be writing the string or printing the string systems. So total number of characters available in the string systems is 7. So now what happens is, as the first step, this particular line will be executed, which will move the cursor of the LCD to first row first column, and following that this particular line will be executed, which will print the word embedded onto the first row first column of the LCD or from the first row first column of the LCD. And following that, this command will be executed, that is the third line in the program will be executed, which will be moving the cursor of LCD to second row first column. And finally this particular line is useful for printing the string system from the second row first column of the LCD. So as a result, the embedded string will be printed from the first row first column of the LCD, and the system string will be printed from the second row first column of the LCD. So this is the expected output of this program written right over here. So I'm just building this. You can see the build is successful with 0 errors and 0 warnings. I have already connected my development board to the PC through USB cable. Now right click on this RL78 even debug tool and hover over using debug tool and select the emulator you want. In my case I'm using even. If you are using E2 or E2 Lite, just select it. Click on this icon right over here or F6 in the keyboard for dumping the flash to the microcontroller. You can see the program is being downloaded to the microcontroller. So you can clearly see I have already connected my 16x2 LCD in the breadboard. So as per the circuit diagram that I have already discussed in this video. So this VSS pin is connected to this rail. You can clearly see this black wire is connected to the VSS pin, which is the ground of whole LCD, and the VDD pin is connected to this rail, that is the top rail, that is the red wire. So I can utilize this rail in the breadboard for powering up the LCD and the second rail in the breadboard for providing the ground for the LCD. And you can see the potentiometer is connected right over here. This is a 10 kilo ohms potentiometer. You can see the value 103. And further you can see RS, RW enable D0, D1, D2, D3, D4, D5, D6, D7 is connected to respective jumpers. And other end of the jumpers I will be connecting it to the microcontroller pins as per the circuit diagram already discussed in this video. And coming to the extreme end of the LCD, that is the 15th and 16th pin, you can clearly see 15th pin, that is the anode of the backlight of the LCD, is connected to 220 ohms resistor, and the other end of the resistor is connected to 5 volt rail of the breadboard. So this is the power supply rail, and the cathode is already connected to ground of the circuit. You can clearly see this is the ground rail of the breadboard. That's it. Now let me just connect all these respective terminals to the GPIO pins as per the circuit diagram that I have already discussed in this video, and then let's see the output in the hardware. Now for running the program, just click on the play button right over here or F5 in the keyboard. The program has been printed in the first row first column of the LCD, and the systems has been printed in the second row first column of the LCD. And using this potentiometer right over here, you will be able to vary the contrast of the font available in the LCD. When you bring the knob to the one extreme end, it will become, contrast will become very low. You will not be able to see the font, and when you bring the knob to the other extreme end, you will get the contrast to the higher value. You will never see anything. All the blocks will be highlighted in black. So this is the output that I got in the hardware. We successfully interfaced 16x2 LCD in 8-bit mode with our RL78 bar F14 series microcontroller. See you in the next video. Thanks for watching.